What's up, everybody? We are ready to continue our journey to help you guys get an amazing score on your next SAT, focusing, of course, for now on the math. These problems that we're going to do, I have 5 of them that I picked from the November 2024 SAT. I think you're going to find to be very satisfying. They're definitely going to be on the somewhat more challenging side. And just do me a super big favor. The only way you're going to get really, really good at these questions is if you don't just watch me, but you have to make sure that you do them in DESMOS alongside me, okay? That way you're going to remember exactly how to do it when it really counts, and that, of course, is during the test itself. Guys, let's get started. The very first question I have here is going to be number 1. This was not number 1 on the test. I would probably say that this would be kind of like a solid end of Module 1, kind of in the beginning of Module 2. So I have these color-coded green, yellow, red. Green is not necessarily easy, but it's going to be the easier of the problems that I'm going to be giving you. For the most part, they are harder because the way you're going to get good at this test is you have to know how to do these hard ones. Here we go, guys. A bed of topsoil in the shape of a rectangular prism has a height of 24 inches, a length of 15 feet, and a width of 3 feet. If the price of the per cubic yard of topsoil is $39, what is the total cost of topsoil to fill the bed with the dimensions given? And they were nice enough to give us some conversion factors. A foot is 12 inches, 3 feet is a yard. Okay, so we are going to use DESMOS to nail this for us. I wouldn't say we're using any of the most powerful features of DESMOS, like regression or its graphing capabilities and sliders, but we're just going to use it as a nice handy calculator. So would you guys agree the first thing we need to do is take those 3 dimensions? Incidentally, a rectangular prism, that's just a fancy word for a box, okay? So anytime you see there, rectangular prism, just think of something that's like shaped like a shoebox. So volume, I'm going to say, is going to be V. And the dimensions, of course, are 24 by 15 by 3, okay? And if you see me going back and forth like this, guys, it's just because I've got this big microphone in front of my keyboard. Okay, now, guys, this is completely wrong, okay? You got to make sure that you read the units, okay? They're very sneaky these days, and I've noticed countless times where students merrily go about solving the problem, but they forget to make sure that their units are consistent. So the problem is here, 2 things. First, you'd have square feet times inches, which wouldn't be consistent. And on top of that, we have to get everything in terms of cubic yards. Why? Because the total price per cubic yard is $39 per cubic yard, and our goal is to get the total cost. So the key to the problem is we need to see that the total cost for all the topsoil will be the price per cubic yard, which is $39, times the volume, okay? So let's get the volume first. So this is not correct because each of these has to be adjusted into yards. So let's go back to our 24, and we want to multiply that by a conversion factor. Now you could do this one of 2 ways. You could immediately see that if you've got 24 inches, then there will be 36 inches in 1 yard. Why is that? Because there's 12 inches in 1 foot, and there are 3 feet in 1 yard. So that's actually a total of 36 inches that you need to make up 1 yard. So the question is, when we put in our conversion factor, do we want to do 36 over 1 or 1 over 36? The answer is definitely 1 over 36. Whenever you're going from the smaller unit, which we are here, which is inches, and you want to get it to the bigger unit, you've got to multiply by the fraction, which is less than 1. So we want to do 1 over 36, okay? Let's move on to the 15. So 15, the units of that were feet, so we have to multiply the 15 by the conversion factor, which is 3 feet in 1 yard. So once again, we're going from the smaller unit of feet to the larger unit of yards, so we have to multiply by 1/3. And we close the parentheses on that, and guess what, guys? We have one more to do, and that is, of course, the 3. That's 3 feet, and of course, we go from feet to yard by multiplying by 1/3, okay? And there it is. So our answer is V equals 3.3 repeating. It's very convenient to assign a variable to your calculation because then that way you're not going to lose any accuracy. And you can use this entire number, 3.3 repeating, with the V. All right, next, in effect, we're creating a slider, but we're not going to slide the value. We're just going to say that the price for the topsoil is equal to $39 per cubic yard. Okay? So I'm just going to keep that as like a static slider. And now finally, we're just going to do the calculation for the total cost will equal P times V. So I write PV, and guess what? We're done. The answer is $130, okay? So we will put 130 into the little answer grid. You can rest assured that you entered it perfectly because it has 3 symbols. And remember, if you're ever dealing with like a bunch of decimals, you have to make sure that you enter 5 symbols worth of accuracy, okay? And if we enter that situation, I'll be sure to make it clear that we've entered the correct degree of accuracy. This one is all set. And we are ready to move on to a slightly harder problem. All right, guys, here comes the second one. Now, I still have this color-coded in green, which means it's on the easier side, but I would say it's a little bit harder than the previous one. Every single time I go to the Reddit comments, this type of problem always comes up, okay? And I want you guys to know how to attack this type of a question once and for all, not have to worry about any crazy percent stuff. Just let DESMOS take care of it for you. Now, you guys are going to love this because we are going to use a pretty cool strategy here. And that strategy is to say, you know what? If A is 484% of B and A is 0.88% of C, then if C is P% of B, what is P? To make sense of all this, what you want to do is say to yourself, wait a second, maybe I have something called a free variable. A free variable is basically one that you could literally assign anything to it, okay? And then once you do that, you're going to see how the problem is going to unfold. I'm going to say that B is my free variable, and I'm just going to say it's equal to 100. You could literally make it equal anything you want, but let's just say B is 100, okay? Next step, let's play off of that first statement, which is A is 484% of B, because now that we know what B is, through our own assignment, we're going to figure out what A is. Now, guys, you have to start getting used to doing equations through a regression. It's super fast, and you get your answer displayed within the line of DESMOS, not as a graph or, like a vertical line. And it's just something that you really want to get used to. It's unbelievably powerful. So here we go. We're going to go A. Now, for is, normally you do equals, but with regression, we do the tilde. To access the tilde symbol, you're just going to do shift, and then it's typically the key immediately to the left of number 1. That'll create the cute little tilde symbol. So A tilde. Now, this is so important. When you do percentages in DESMOS, do not, I repeat, do not waste time stripping away the percent symbol and then trying to be a hero and move the decimal over 2 spaces. It's likely that you could mess that up. So just take advantage of DESMOS's native percent feature. So you're just going to type 44%, and look at that, it even gives you the of, okay? So now we just type B because B was already established as 100. How cool is this, guys? Now, I know it's remarkably obvious that if A is 484% of 100, yes, of course, A will be 484. But now here's the cool part. We're going to do another regression, and we're going to have it figure out what C is. This is the part where it would be a little bit more tricky to do it by hand. Now, when you do a back-to-back regression and you just found out your value, and yet you would love to use that letter because we know that A is 484, you can't do it, okay? I'll show you why. So if I were to type A tilde 0.88% of C, do you see what happened there? It gives me garbage values. It's basically saying, hey, I can solve this equation for you guys if A is 0 and C is 0, which makes sense because 0 is equal to anything times 0. But of course we don't want that. And the reason it's not working is that DESMOS is basically wiping the A from memory, and it's basically creating a fresh regression for us. Okay, so instead what you have to do is either type the number or simply copy it in. I'm going to copy it because I feel it's a little bit safer. And boom, look at that, guys. Now we get a legitimate value for C. C is equal to 55,000, okay? And now we're ready to finish this off. Let's seal the deal. So C is P% of B. What is P? So again, just translate it as you normally would any math equation, but just put it directly into DESMOS. So you're going to go C, but am I going to type the C? No, I'm not, because remember what we just said. When you do a back-to-back regression and you're trying to use the very variable that you just solved for, you actually have to enter the numerical value. So we will copy the 55,000 just like this. So we do the standard Control-C, Control-V, and then we're going to go tilde because that's your symbol for regression for equal sign. And then we type P% of, And then b you can type. You can type it. Why? Because b is up here. It's equal to 100. That's locked in. That wasn't like done through a regression. And look at that, guys. Your answer is 55,000. How cool is that? Now, I want to show you something. There's absolutely nothing special about making b 100. I don't want you to think that, oh, I picked that in advance because I knew it was the only sneaky value that would work. Nope. Let's just pick a completely random number. How about 47? Okay. So now a is 484% of b. Now a is a completely different number. It's 227.48, right? So that means I have to get rid of this 44 here and replace it with the new value of a, which is 227.48. So I copy it, I pop it in, and I get a new value of c of 25,850. What am I going to do with this 55,000? I'm going to delete it and replace it with the new value of c, 25,850. Pop it back in. Kapow! Look at that. P is 55,000, guys. It doesn't change. This is what I mean about a free variable. You can let that b equal whatever you want. And in fact, you didn't even have to use b as your free variable. You basically could have used a, you could have used c. It really doesn't matter. Maybe one will be a little bit easier than the other. For me, I felt that just by letting b equal 100, it would just set this off and make the problem really easy to solve. I hope you guys agree that this is super easy, and now you're not going to have to do all that clunky handwork, okay, where you're so much more likely to make a mistake, fiddling with the calculations. Here you could just see it directly in DESMOS, right? It's seamless. It's integrated directly into DESMOS. You're not going back and forth, losing focus. I hope it makes sense, guys, because they are repeating these questions over and over again. They are recycling the same questions, but with just different numbers and different variables. So make sure you understand how to do this. Practice it on your own, okay? Hope you like that one. So the answer we're going to type into the grid would be 55,000. Notice that has exactly 5 symbols. So we just made it. You have nothing to worry about. Let's move on to the next problem. All right, guys, here comes our third problem. Now it's yellow. It's a little bit harder. What do we got here? We've got 17x squared minus rx minus s equals 0. So obviously we have a quadratic equation. If one of the solutions to the quadratic equation shown above is the square root of 442 divided by 17, what is the value of s? Okay, things are definitely getting a little bit harder. And I have to admit that although DESMOS is going to be really helpful here, there's 2 key things that we have to know in order to solve this efficiently. The first thing is that if you know that one of the solutions is the square root of 442 over 17, the other solution is going to be the conjugate of that. So it's actually going to be negative square root of 442 over 17. That's just a consequence of when you look at the quadratic formula, you have negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you only have the square root component, then it must mean that you have the plus or minus of that, thanks to the quadratic formula. So the bottom line is I'm going to say that R1, by the way, to get a subscript, you literally type the number immediately after the variable, is going to be equal to the square root of 442 over 17. I'm just saying that one of the solutions or one of the roots is exactly that. By the way, to get a fraction, you could either type the fraction bar, which is the one combined with the question mark, or you can type frac, whatever you prefer. For the square root, you want to type SQRT. And that's going to be 442 over 17. Okay? There it is. So the first root is 1.23 and so on. Now, the second root is going to be the same thing but with a minus sign in front. Let me teach you another cool trick, guys. Hit the gear icon and let's hit the copy button because we just simply want to reuse that exact same value except change the R1 to an R2 and put a minus sign in front of it, okay? And again, why am I putting the minus sign? Because if you have a solution to a quadratic equation and it involves a square root, then the other solution must be the conjugate of that, which effectively is the negative of it. All right, now comes another cool piece of quadratic knowledge. When you have the product of solutions, it is going to equal c over a, okay? So in this case, c would be the constant term, which would be negative s, which is perfect because we want to solve for s, and a would be the coefficient of the quadratic term, which is 17. So now do you see why, guys, we needed to figure out what the other root is? Because we're going to make use of this cool product of the solutions is equal to c over a. So guess what? We're going to go product of the solutions in DESMOS, so that's obviously R1 times R2, tilde, okay, we're going to do a regression, and it's going to equal C over A. My C value, of course, is -7, -S, and my A value is going to be 17. And boom, done. Guys, we're done. That's it. The answer is 26, and look how clean and beautiful that is. We didn't have to do a shred of work on paper. We didn't have to get entangled or embroiled with any horrible calculations. DESMOS did everything for us nice and clean. I mean, you couldn't ask for a better approach. But having said that, guys, you do need to know those two rules. Solutions come in conjugate pairs, and you also have to remember that the product of the solutions is equal to C over A, okay? C is the constant term, and A is the coefficient of the quadratic term. Hope you like that one, guys. Let's move on to the next. All right, guys, we are on number 4, and as you can see, it's still got a yellow difficulty rating, but don't worry, the last one is going to be red for sure. I kept the work that we had here just for the fun of it because I wanted to just show you a quick little hack. Rather than going XXX on all the lines of your calculations, just hit the gear icon and then delete all, okay? And then everything will disappear and we can start on a clean slate. Let's read this one. If the function f of x equals a to the x minus b passes through the points c, 8 and 2c, 118, what is the value of b? Once again, guys, we are not going to do anything on the paper, okay? By the way, I'm not saying that I'm advocating that in every single case you never touch the paper. In fact, I always make sure that my students have 4 pages when they come in to do a diagnostic test. You absolutely have to use the paper in some cases, especially if there's like a geometric figure involved. You want to draw that sucker on the paper, start labeling the dimensions, try to find some clever approaches to solving the problem. There's other situations as well. But I'm really here to show you guys how to crush these questions with DESMOS because it is such an incredible tool. So what are we going to do here? We are going to immediately create a table. Now, as you do more of these for practice, you're going to know exactly when to start creating a table. Whenever you have points, there's a great chance that a table is going to come to the rescue. And from that table, you will be able to create a regression, okay? This is different from the regressions we've done so far. The regressions we've done so far is just simply solving an equation outright. But remember, DESMOS can actually find those annoying constants for you, those A's, B's, C's, and K's, when you give it some points and tell it to do a regression. So let's go for it. Now, to do a table, type table, okay? That's the fastest way to get it. By default, you'll get an X1 column and a Y1 column. Do not be afraid to type in one of the constants in the table as well. So I'm going to put that C there for X1, and I'm going to put in the 8 for the Y1. Use tab, by the way, guys, to go from one cell to the next. And then down here, for the second X value, I'm going to put 2C. And then for the Y value, I'm going to put 118. Okay, guess what? We're done with our table. And now you're thinking, yeah, but Art, you have a bunch of errors. Yeah, but guess what? I didn't define C yet. Now I am. I'm going to say C equals, you can set it for whatever you want. I'm just going to start with 2, okay? So C is 2. Again, that shows up as a slider, but did you notice those errors in the table vanished because now DESMOS sees this as the point 2, 8 and 4, 118. Okay, now comes the regression. So we want to do y1, which essentially is the same as your f of x, tilde, and we're going to go a to the power of x1, and we're going to go minus b. Okay? Now, you have your values here of a equals 3.31662 and b equals 3. Now what I'm going to do is move my slider. And do you notice something interesting, guys? No matter where I put C, right, my value for B stays the same. So the fact that that's the case must tell you that you're all set. It knows exactly what the B value is, irrespective of what the C is. So that's pretty sweet. And, you know, it's nice to see the graph, but the graph itself is, in this particular case, I wouldn't say is incredibly helpful, but it is there just so you can see it. And notice that the points are tracked on the graph. There's the point, which is now 5.7, 8, because C is at 5.7. And then the other one, of course, would be a little further up. And there it is. Now it's at 11.4, 118. Okay, so there you go. The answer to this problem is 3. And once you practice these guys, I mean, that is like for sure under 30 seconds. Okay, let's move on to the grand finale. All right, guys, here we go, the grand finale. This will be the hardest one, at least in my opinion, of the batch of 5 that I have for today. A circle with equation 2x squared plus 2y squared plus tx plus ty minus 60 equals 0 has a radius equal to the square root of 32. Which of the following must t equal? And this is a multiple choice question, which is pretty cool because, as a rule of thumb, multiple choice is a little bit more relaxed in the sense that A, you can use strategies because you could just test the answers and you could literally plug those in one at a time for t. And 2, you don't have to be as, it's not as nerve-wracking when you have to enter those numbers into the student response and you have to know that those numbers have to match exactly, okay? So bottom line is you have a little bit more forgiveness when you do a multiple choice question. All right, let's have at it. So the first thing we're going to do is we're going to enter this equation directly into DESMOS, okay? So we've got 2x squared plus 2y squared plus tx plus ty minus 60 equals 0. And of course, we're going to accept the slider in this case for t and look at this nice juicy circle that we get, okay? We'll set it right here so that we can see everything going on. Okay, what's the next step? Well, why don't we set the slider t equal to the first answer choice, A. So we're just going to say t equals 0. Notice, by the way, guys, you do not need to slide it manually with the slider. When you have discrete values, and there's only a few of them you're testing, just simply enter it directly into the slider value, okay? So again, we're going to make t equals 0. Now, how do we know if t equals 0 is the correct answer? Easy. The circle has to have a radius of the square root of 32. So what we're going to do is determine the radius, and we're going to do it in a super cool way. We're going to use DESMOS' distance formula. So if we can give it 2 points, it'll calculate the distance between those 2 points, and if we cut it in half, then we can get the radius. Because the 2 points we're going to use in this case are going to be the opposite ends of the circle, which would form the diameter, okay? We're going to click this point right here. By the way, DESMOS circles always has clickable points on the north and south pole, okay? So 0, 5.477, and then the bottom one is 0, negative 5.477. So what I'm going to do is, actually, I think we can check this one pretty easily because the circle is pretty obviously centered at the origin, right? Because of the symmetry of the y values. Why don't we just figure out what the square root of 32 is, because we might have gotten lucky. So let's go square root of 32, and we want to see if that would equal the radius, which would be from the origin to this uppermost y value of 5.477. And sadly, that doesn't work. It's not good enough, right? Because the square root of 32 is 5.6568 roughly. So we're off a little bit. And how far off is hard to say. So why don't we just now make it 2, okay? And notice that the circle is no longer centered at the origin, so we have to be a little bit more careful, right? You have a point here at 0.5 and another point at negative 0.5, 5.023. That's the one we want because that's a little bit higher up. So what we're going to do is a rather clever thing, and that is we're going to assign to the letter A that particular point. And we're going to just say A equals, and remember, when you do a point, you need parentheses. So we're going to go A equals, and let's get that point one more time. It's negative 0.5, 5.023. So negative 0.5, comma, 5.023. And look at that, isn't that cool? You got a nice little dot appearing on the North Pole. We're going to do the same for the South Pole. We're going to say B equals, and again, it's going to have the same x coordinate, so negative 0.5, comma, and then the y value is negative 6.023. So let's put that in. Negative 6.023. Now check this out, guys. Watch this. We're going to go distance, and notice it appears as a function, all in nice letters, and it's a function, so therefore you have to use parentheses. And because we already assigned the points to A and B, the inputs to the distance formula are literally going to be A comma B, because it knows what those values are, and you get 11.046. However, that's the whole distance from the purple dot to the black dot at the bottom. So what do we need to do? Obviously divide that by 2. So I'm just going to put a 1/2 in front of the distance formula. 5.523, is that the right answer? No, sadly it's not, because we're trying to get it to match what I wrote in line 3 of square root of 32. That's the radius we're trying to get, okay? So let's try 4. Okay, and by the way, if 4 doesn't work, then the answer has to be 6. So we're literally just testing 3 answers in total. So now I'm going to make it 4. And notice that my purple and black dots are no longer on this circle. That makes sense because it's changed the equation of the circle. And now what are we going to do? We're just going to click on that topmost point. -1, 4.657. So I'm going to change A to -1. And I think it was 4.657. So I update my coordinates, 4.657. And we're going to go to the South Pole. And we're at -1, -6.657. So here we go. -1, -6.657. And whoa, guys, look at that. Okay, now you should use good math judgment, good number sense, and say, yep, we got the answer. Because you're trying to get to 5.657-ish if you round a little bit, and this is 5.567. So yeah, so the reason it's not matching this exact decimal is just that DESMOS is doing a little bit of rounding off. It might have to do with my zoom factor. I'm not 100% sure, but either way, you have nothing to worry about because common sense would tell you that if you attempted to try the answer 6, it's going to be much further off. Therefore, the answer is 4. And how cool is that, guys? We didn't have to waste any time doing any completing the square stuff. We just put this directly into DESMOS, type the equation as is, we create a slider for t, and we just simply test each answer choice until that slider value creates a circle with a radius equal to the square root of 32. Just remember, click on the top point of the circle and create a variable to name that point. Click on the bottom of the circle, create a variable for that, and then you just need to simply enter those variables into the distance formula. Yes, you could have used the points, but I think it's much easier to just enter the letters. Incidentally, if it asks for the midpoint of the circle, guess what? Just type midpoint. And of course, midpoint would require the endpoints, which we established were A and B, and boom, look at that cute little blue dot. Click on it, and there is the midpoint of the circle. It will be at -1, -1. So there you have it, guys. I hope you enjoyed this first little series of questions from the November 2024 SAT. There will be many more to follow. I would say that overall there was at least 30 questions from this test, so expect there to be at least 4, maybe 5, even 6 parts just to dissect all the questions from the November 2024 SAT. You are going to study these guys like your life depends on it because, again, these questions are being recycled from test to test. They're just using different variables and different numbers. So study them, memorize them, and you are going to succeed on your next SAT. I hope you guys enjoyed, and I'll look forward to seeing you soon for the next round of a DESMOS approach to the digital SAT math.